In this slide, we'll show the DFT for n equals to 4. The question begins like this. Calculate the 4-point DFT of an aperiodic sequence xn, and we're given this xn here, and we are asked to find the DFT coefficients. So remember that when we give you a 4 sequence number, we basically is asking you to apply this equation for the analysis equation. You put x as a column vector, you generate the W matrix, and all you are doing is basically calculating the capital X. The DFT coefficients is equals to the W DFT matrix multiplied by the X, the input. You'll get a column vector which is a complex numbers. Some have no J's, so this is basically 5 plus J0, and some have J's. That's it. And how do you interpret these coefficients? Nothing but this will be capital X0, this capital X1, capital X2, and capital X3. And here we're talking about the index letter k from 0 to n minus 1. Right. Then what about inverse DFT? Well, we then use the same coefficients we found, and then we're now asking you to find xn. And remember in our previous slide, we show you that the synthesis, that means converting from a capital X, the DFT coefficient, back to the time domain, is using 1 over n WH times capital X. We put X, capital X here. We put the WH matrix here. We put a 1 over n here, and we do 1 over n multiplied by WH multiplied by capital X. It will give us small little x n. So you realize that DFT and inverse DFT can simply be viewed as matrix vector multiplication with the corresponding W's. Now, if you do it by brute force, the computation is n squared. So if you're using MATLAB or Python libraries for DFTs, discrete Fourier transform, internally they are evaluating it as a fast Fourier transform. And the fast Fourier transform uses n log n, while the brute force DFT uses n squared operation. And when input n is in the region of 1024, then the saving is tremendous. So you see that the computation required for FFT is only about 10,000 operations, while in the DFT we're talking about a million operation here, just for a small size value of n equals to 1024. With that, we're done with this slide. Thank you.